Hello there, welcome to this video on solving right triangle problems in context, specifically angles of elevation and angles of depression. We're going to go ahead and we're going to look at more word problems in this video, and we're going to be given information about an angle of elevation, an angle looking up, and then an angle of depression, which is an angle looking down. So we'll go ahead and we'll look at some of those cases. Our objective, solve problems involving the angles of elevation and depression. All right, for a prior knowledge, they want you to just write an equation. What's the equation to find x? And then find x. Round to the nearest tenth. Pause the video, give this a go. All right, hopefully you went ahead and first labeled the sides. We have opposite and we have hypotenuse. So that is SOHCAHTOA. Sine function is the winner. So sine of 34 is equal to 16 over x. There is your equation. And then solving it, you should have gotten x is equal to 16 over sine of 34, which if we go ahead and calculate that, 16 divided by sine of 34, wrong button, shortcuts right there, about 28.6, 28.6 is x. All right. Okay, so first let me go ahead and talk to you about what an angle of elevation and an angle of depression is. An angle of elevation is the angle between a horizontal line of sight, so just you looking straight, if you were just walking straight, looking straight, that's a straight line. And then if you looked upwards, you looked upward at something, maybe like a bird in a tree, maybe a plane is flying by overhead. Something to where you're looking up. Maybe you're looking up at the top of the building, or you're looking at a ceiling. You can go ahead and form that angle. So from a straight line up, that's your angle of elevation. You can see an example of it here. An angle of depression is formed between a horizontal line of sight when looking downward. And the most common one we experience of this, imagine if you're just looking straight, and then all of a sudden your phone buzzes and you look down at your phone, you just created an angle of depression. Okay, here's a context and one that these math problems love the most is someone on top of a cliff, and then they look down. Here is an angle of depression. Just a warning with angles of depression, they're not usually a part of the triangle, and I'll go ahead and when we get to angle of depression questions, I'll show you how we put those into the triangle. But warning, whenever they give you an angle of depression, that's not a value usually in the triangle. Heads up. Okay? All right, so here is our first example. They say the angle of elevation between the ground and the top of a cliff is 34 degrees. Okay, so they just gave us an angle of elevation. Here is the ground. Here's the top of a cliff. So angle of elevation, 34 degrees. Okay, so I just place that information. Then they say if a person is 1,000 feet from the base of a cliff, how high is the cliff? Okay, so I know that this distance is 1,000 feet, and then we want to know how high is cliff. There's cliff. Okay, round to the nearest tenth of a foot. All right, so what did they give us? Well, they gave us an angle, which is here. We need to find the opposite side, and we're given, not tangent, my brain's working ahead. We're given adjacent, okay? So I know that this function with SOHCAHTOA is tangent of 34 degrees is equal to the side opposite over the side adjacent. Okay, now I can go ahead and solve this. I'll multiply both sides by 1,000, and we get x is equal to 1,000 times tangent of 34. So we need to go ahead and compute this. So 1,000 times tan of 34. We get 674.5. 674.5. Approximately 674.5. And this is in feet, I believe. Yeah. Okay. All right. Round to the nearest tenth of a foot. We did that. Okay. So we need to answer in a question. How high is the cliff? The cliff is 674.5 feet high or tall. Something to that effect. All right, here's an example problem, or a practice problem, if I will, for you. They say a flagpole is 35 feet tall. From a schoolhouse, the angle of elevation between the ground and the top of the flagpole is 67 degrees. How far is the schoolhouse from the flagpole? Round to the nearest tenth of a foot. Pause the video. Give this one a go. All right, hopefully you paused this. Based upon the information, they say that the flagpole is 35 feet tall. There's an angle of elevation from the base of the schoolhouse to the top of the flagpole that's 37 degrees, and they want to know how far is the schoolhouse from the flagpole. So there is your equation. Again, this involves opposite and adjacent. So this is tangent. So tan of 67 is equal to 35 over x. And then you should have solved and gotten this. So 35 divided by tan of 67. Okay, and there is your answer. About 14.9 feet is the distance between the schoolhouse and the flagpole. Pretty easy, right? Angle of elevation. They'll give you two things, and you're just placing it in between those two things. All right, here is our next example. They say a person is standing 32 feet from the base of a tree. The tree is 48 feet tall. What is the angle of elevation between the ground and the top of the tree? So here's the ground, top of the tree is up here. So that's what we want to find. They say, what's the angle of elevation? So it looks like here I'm solving for a value. Okay, well, I'm given information about the side opposite and the side that is adjacent. So again, this is tangent. Tangent of x is equal to 48 over 32. And if I want to solve for x, I'm using an inverse function. So tan inverse of 48 divided by 32, that's going to give us our angle of elevation. Okay, so let's see. Tan inverse of 48 divided by 32. And we get 56.3, so just 56 degrees. 56 degrees. The angle of elevation is about 56 degrees. It's a big degree symbol. Almost looks like 560. Better. Okay. Here's a practice problem for you. Please pause the video. Again, I'll throw in the information into the diagram, but try it first and then solve the problem. All right, hopefully you pause the video. They tell you a person's 43 feet from the base of a building. So here's the 43 feet. If the building is 56 feet tall, okay, so this is 56 feet tall. What's the angle of elevation between the ground and the top of the building? Well, you're finding this angle, angle x. If you haven't tried solving, pause the video and solve now. Okay, hopefully you went ahead and solved this. Again, this is a tangent value and we're solving for an angle, so it's tan inverse of 56 over 43. So that would be your equation. And then your answer is approximately 52 degrees. Did I write that one here earlier? Right? I did. That's right. Okay. Good. All right. Now we're going to dive into the angle of depression problems, and there's kind of a new wrinkle in these, because I said earlier, when they give you an angle of depression, notice, let me go back up to here, they don't give you any information about an angle inside of the triangle. It's that angle of depression that's outside of the triangle. So what we want to do is we want to go ahead and use our idea or our knowledge of transversal line going through two parallel lines. And here's an example of stuff that you covered in Math 2 about, I have two parallel lines cut by a transversal. Well, two angles formed are congruent, and they're called alternate interior angles. They're going to be exactly the same. And it works too for the other angles. These are alternate interior, alternate sides of the transversal on the interior of the parallel lines. So why is this important? Well, this is important because when problems give you angle of depression here, what they're really giving you, if I use my knowledge of alternate interior angles, is the angle that is on the opposite side of that line of sight inside of the triangle. Okay, so we're using our knowledge of alternate interior angles. Those are congruent angles. So we're going to use that information. Make sure you fill this in if you need to here. The angle of depression and angle A are alternate interior angles, and therefore they are congruent. Okay, here is our first example. They say the angle of depression from the top of an 80-foot building to a person on the ground is 42 degrees. How far is the person from the base of the building? Round to the nearest tenth. Okay. Angle of depression from the top of an 80-foot building. Okay, so I know that this building here, this distance is 80. And then the angle of depression is 42 degrees. Well, again, when they give you angle of depression, when they give you this, they're really giving you this angle right here. So this is 42 degrees. Okay, and how far is the person from the base of the building? So I want to solve for this distance here. All right, well, I'm given the side that is opposite. I want to solve for adjacent, so this is tangent. It seems like all of these problems are tangent. What's going on? Tangent of 42 is equal to 80 over x. You guys are going to be pros with using tangent. All right, so we'll go ahead and solve. I'll multiply both sides by x. So x times tangent of 42 is equal to 80. And then solving for x, we'll divide both sides by tangent of 42. Tangent of 42. Okay. So x is equal to 80 divided by tangent of 42. And we'll go ahead and compute this. So 80 divided by tangent 42. And that is 72.0. So approximately 72.0. Units, we're talking feet? Is this feet? Okay. Feet. So the person is about 72 feet from the building. There you go. All right, next example. Here they say a water slide is 100 feet long. The angle of depression from the top of the slide to the person on the ground is 78 degrees. What is the height of the water slide? Okay, well, they give us this image here. They say the water slide's 100 feet long. Okay, so that's this distance, 100 feet long water slide. The angle of depression from the top of the slide to the person on the ground is 78 degrees. So they're telling us, hey, this here is 78. Well, again, that's not part of my triangle, so I need to go ahead and use my knowledge of alternate interior angles and place the 78 down here. Okay, then they say, what is the height of the water slide? Height, straight up. So there's X. That's what we want to find, the height of the water slide. Okay, let's go ahead and find out, what are we given? So if I'm using this angle here, 78 degrees, I know that this side is opposite, and I'm given hypotenuse, okay? So that's going to be sine, opposite over hypotenuse. Sine of 78 is X over 100. So there's the equation, and now I just need to solve. I'll multiply both sides by 100. And we get X is equal to 100 sine of 78. Okay, we want to round to the nearest tenth, they say. Round to the nearest tenth. So I'll plug this in. 100 times sine of 78. We get 97.8. 97.8. 1, right? 1 is less than 5, so $97.8. Okay. The height of the slide is about 97.8 feet tall. Short. Tall. Short. However you interpret that. All right, here is a practice problem. Please pause the video. Give this one a go. All right, hopefully you paused it. Here they tell you the angle of depression from the top of a sheer cliff to a boat in the water is 58 degrees. Now when they do that, when they give you this, they're really telling you that this angle is 58 degrees. Then they say if the boat is 250 feet from the base of a cliff, find the height of the cliff. Okay, so that's this side, X. All right, well, I want to find opposite. I'm given adjacent, that's tangent. So tan of 58 is X over 250. And you just have to solve that, which gives you about 400.1 feet. All right, here is the next example. This one's fun. Pause the video, then I'll talk about kind of the placement of the information for this one. Oh, also too, there's a word in here that often throws off students, and it is altitude. Altitude is just height. Altitude is equal to height. Did I spell height right? I before E. Height? I don't know. I felt like the first one was better. Height. Yep, I think height. That's right. All right, yeah, altitude. It's just height. So when a plane has a certain altitude, that's how far up in the sky they are. Okay? All right, pause the video. Give this one a go. Hopefully you tried this one. They tell us that the airplane has a pilot that sights an airport with an angle of depression at 26 degrees. So putting this inside of our triangle, 26 degrees is down at the bottom. That's actually an angle of elevation from the airport up to the plane. It's the same thing. Then they say if the altitude of the plane is 7,300 feet, okay? So this is 7,300 feet. 7,300 feet. What is the plane's horizontal distance to the airport? So you're trying to solve for this. All right, if that kind of confused you, pause the video, go ahead and solve from here. Okay, hopefully you went ahead and solved it. Based upon this information, we get tan of 26 is equal to 7,300 over d, where d is the distance from the plane horizontally to the airport, and that is about 14,967 feet. All right. Okay, closure. Last question. Here they say from a lighthouse on the shore, a ship in distress is spotted at an angle of depression of 18 degrees. If the lighthouse is 50 feet tall, how far from the shore is the ship? So which of these equations can help us solve? Go ahead and pause the video and give it a go. All right, hopefully you got D. Tan of 18 is equal to 50 over D. Again, this distance, or this angle here is 18 degrees based upon alternate interior angles. I have the opposite side and I want to solve for the adjacent side, so that's tangent. Tan of 18 is 50 over D. Alright, hopefully you liked this video. If you did, give it a thumbs up. If not, still give me a thumbs up because that's nice and kind, and I would appreciate it. Thank you. Subscribe for more awesome math content. I'll catch you next time. Peace out.